People don't realize this, but IISc was very entrepreneurial in many ways.
I think your life is an epitome of that. You started with engineering, mathematics background, then you went on to computational biology, then you went on to genomics.
So when we went and demonstrated this software in Japan, they were willing to become distributor. And one of them was Hitachi.
The stories like Simputer and Strand Life Sciences, I personally feel should be the part of curriculum for students and colleges and schools.
And the 20% we were taking away from American companies. So the American companies suddenly noticed us.
Hello and welcome to this incredible new episode of Science Unblocked, a podcast by Blockchain for Impact. I am your host, Dr. Gaurav Singh. Today, it's a personal fanboy moment for me because with us is one of the most revered scientists of India, the man who is known by many names like the Genomics man of India, father of Indian bioinformatics, and the Bhishma Pitamaha of Indian biotechnology. For me, he's like Nostradamus and Baba Vanga, because what are the new technologies we talk about today, like AI, CRISPR, and quantum, Sir has been working on this since past 2 decades. So I heartily welcome the Dhurandhar of our Indian science, Dr. Vijay Chandru.
Thank you.
Sir, it's incredible to have you here. I'll just give a brief about Sir's journey. Sir was born and brought up in Madras and then did his engineering from BITS Pilani. Then Sir went on to do his master's from UCLA and then completed his PhD from MIT. Sir was also a faculty at Purdue University and then he came back to IISc, and this we're going to ask Sir that what made him come back to India after having such a wonderful career in US. And after that, he found out companies like Strand Life Sciences, CRISPR BITS, and there is a lot of stories that we can hear from Sir himself. We would love if you can take us through your journey in life, especially the moments that you like the most.
Thank you, Dr. Gaurav, for having me on this podcast. You said many complimentary things. I hope I can live up to that. But just to go back, I think it was a very privileged childhood. I grew up in Madras with my maternal grandparents, and my grandfather was a pioneer in the film industry. Those days, Madras was where, or Chennai now, was where all South Indian films were made, all languages. And so Telugu films were what he specialized in. And it was just a privilege to be in his company. He eventually became the first South Indian to win the Dada Saheb Phalke Award. So he was a very respected filmmaker. But I was just a kid, and I was quite excited about cricket and the usual stuff. I think I wanted to be an engineer by the time I was 11 or 12, but BITS Pilani gave me that opportunity after high school. And so Pilani was, a big change. First leaving grandparents in Madras and then going all the way to Rajasthan. But it was also life-changing. I was more an all-rounder as an undergraduate because I was keen on cricket. I played captain the university. I used to be in a lot of sports, theatre. Just barely got good enough grades to get into a good graduate school. But I was an electrical engineer by training. So that's been the early part of the journey.
Sir, so you had the opportunity to be the Shah Rukh Khan and the Rajnikant of Telugu industry. You also had the opportunity to become the Sachin Tendulkar of India. But you chose science.
I was not that good in cricket. But certainly, I mean, if I had really been keen on wanting to go into the film industry or, acting and so on, opportunity was there. Although I think by the time I was growing up in the 60s, my grandfather was actually a little disappointed with how commercial the industry had become. So we were kind of shielded a little bit. I used to go often to the studios to watch recordings and also to go on field trips with the film crew just to see different parts of the country when I had holidays. So I had a sense of that industry, but not. I was always more drawn to, as I said, engineering and science because my father had been a zoologist and later became a civil servant, so there was also an exposure to science and technology.
You're a prime example of anti-nepotism in Bollywood. That's all I can say.
No.
It's good for Indian science that you chose science and not the other avenues that were also highly available. Any thoughts on your journey at the US and what made your thinking change after going to US? When you were in BITS Pilani, you would have a certain mindset, and when you went to US and spent so many years there, so what difference did you see from India to US in the mindset of a person that actually goes through this?
In terms of the technical orientation, I think that was fixed in Pilani. And Pilani BITS had a lot of very interesting visitors who exposed us to many new ideas. And in particular, one visitor called Dr. Stafford Beer from the UK came during our final year at Pilani, and he was one of the founders of cybernetics. In UK, he was kind of the figure in cybernetics. Of course, in the US, you had Norbert Wiener and several others who were also driving cybernetics. And cybernetics, by the way, was about intelligent control. So in a way, this was the early AI, and I basically jumped into that field and eventually did my PhD in a corner of that in mathematical optimization methods, which came under the purview of decision sciences, operations, research. But about the American experience, I would say that there were a few things that stood out. One was, of course, the amazing flexibility in the university. I could take electives in ice skating or swimnastics, and even as a graduate student, and UCLA was okay with that. UCLA actually did something very useful for my professional life, because in order to qualify to be a teaching assistant, you actually had to go through a recording of a mock lecture. Okay. And they would videotape it and then give you advice on Blackboard style, looking at the class, all these things, which for me became like theater, right? After that. And so, in many ways I've said I've not missed being in theater, because teaching is really like performing on stage.
That is so true, sir.
Right. So that was very helpful. Of course, academically, UCLA was also exceptional. The systems, science, and engineering systems departments were where I hung out. And but when I started looking at optimization, MIT had a lot more focus on that. So I decided to, and also, going to MIT was kind of a dream, because BITS Pilani had been set up with MIT collaboration.
Okay.
And so it was like going to the mother node, right, for the doctoral work. And it was exceptional, of course, the experience at MIT. MIT, I think, stands out also because people work very hard, right? And, the first thing we were told as graduate students is sleep is only optional, right? Of course, that was an exaggeration, but it was also a very hands-on place. So, as an engineer turned mathematician, computer scientist, you could see, people who were very strong theoretically also building stuff, and people who were doing very applied work also, understanding the theory very well. So it was a very good blend of these things, and I think that particularly was an experience that I think made me make certain choices, right?
Right.
After leaving MIT as well, that I always made sure that even if I was working on very theoretical aspects of computer science, we were also building stuff and doing more hands-on building.
Sir, you have mentioned in your writings many times about your mentor, Dr. Shapiro.
Right.
And we love to know more about him. How was
Right.
he and what impact did he had on your life?
Right. Yeah. So, Dr. Jeremy F. Shapiro was my assigned PhD guide. The mentoring that he gave me one was, taught me a lot about discrete optimization, which was what I eventually worked on for my thesis. But what was very interesting about him was that he was fearless about jumping into new topics, learning a new area, and and making contributions. And I think basically that was an influence for me, because I think when you're trained in areas like AI and cybernetics and of discrete optimization and so on, you can always find applications in many different domains. And being open-minded about jumping into new application areas was, was sort of the natural tendency that he, as a mentor, inculcated in his students. And so I was fortunate to get that. I think in the US, there was a very early recognition that you have to build interdisciplinarity into academic centers of excellence, and that was partly encouraged by the funding agencies, who by the 1980s were no longer doing only PI-driven granting, right? A substantial part of NSF budget, or particularly DARPA, DOE, or the Department of Defense funding would often go for very large team projects, and which were very directed. So in the 1980s, for example, there was a realization that America was losing out to manufacturing, which was going away to Japan, and not China was not in the picture yet.
Okay.
But I think so NSF said, well, we need to also think about manufacturing. So we got a big grant for flexible manufacturing systems, which meant that we had started working in robotics and various aspects of flexible manufacturing. Right. So I think, and it was always interdepartmental. There were people from mathematics, computer science, engineering, various disciplines of engineering, and who could all work together. And I think that is something that I think we've not been as quick and as effective in India. But
that is so true, sir.
Right.
This interdisciplinary interventions that we are discussing today,
Right.
I think your life is an epitome of that. You started with engineering, mathematics background, then you went on to computational biology, then you went on to genomics.
Yeah.
So I think that is also my observation by talking to people like you, that when we work on the interfaces of the various departments, then only I think
Right.
new products, new ideas, and new innovations comes up. So that does not answer the real question for me up till now. What made you come back to IISc, sir?
Okay. Well,
Because you said that you were pretty
Sure,
happy
sure.
in US, and
Yeah,
you were
yeah.
inventing, you were doing things, and then you came back to IISc, to a very different culture and to a country that is still struggling to get up in the science community.
Sure. Well, I think there were a few factors. One, of course, was my father comes from an old Bangalore family, so I was certainly visiting even during the early 80s while I was teaching at Purdue. And every time I came home for a visit, instead of just hanging out with family, I would also spend time at IISc. So come for the summer, but then spend a few weeks with colleagues at IISc and learning what was happening and so on. So when in the US system, when you get tenure, you're also eligible for uh, a sabbatical, right? So I used that sabbatical to come back and I spent almost 18 months in 1988 to 1990. Um, that being at IISc, teaching, interacting with folks there, and also working with DRDO. So I worked with the Center for AI and Robotics. And I think I was very open to the idea of moving back after that experience. Now, what actually were some factors was that I had never thought of myself as an immigrant, right?
Okay.
So for me, going to America, was to get that training in graduate school, and then suddenly a job opened up at Purdue, and it was an interesting job. And what I had in my mind was I'll work for 2-3 years and then come back. But then they gave me tenure, so it sort of got a little extended. In the U.S. Academic system, they sometimes assign you to an American family as a foreign graduate student. And one family had asked for a student from India, and so I got assigned to them. And they turned out to be real family for me. And these were family called the Oakleys. And Gilbert Oakley, Gil as we called him, was actually someone who had lived in India. He had been sent by Ford Foundation to set up IIT Kanpur and BITS Pilani. Unfortunately, he got affected by cancer, and he was quite ill in the early 80s. And so he summoned me. I was already at Purdue, so he summoned me to Boston because he wanted to talk to me. And this was just before he passed away. And so he actually told me, go back to India. I think that was.
We owe a lot to Gilbert for sending you back to India.
Thank you. So, but it was great fun to return to India, permanently. This was early 90s, and then computer science at Indian Institute of Science was probably the leading computer science department in the country. We were also probably the strongest AI group in the country, and so I had excellent colleagues, very bright students, and a lot going on at IISc, which intellectually was absolutely on par with where I had been in the US. I think so. I had no regrets on that front, and of course, financially it was a bit of a setback, but that was okay. I mean, we had planned for it, so okay with that. And to some extent, I guess I had a little bit of a family backing as well in all of this.
Sir, you are very fondly termed as the first academic entrepreneur of India. And how did it all happen? And especially the Simputer story, audience will love to know.
Sure. Yeah, absolutely. So as I said, we had this lab together, and we were learning to build fairly complex systems, and because we were consulting, we had a lot of flexibility in funding. So we were able to do things that perhaps other academic groups had difficulty with. I think around 1998, two things happened in that year. In IISc, the new president of the court of IISc was Mr. Ratan Tata. And he actually, made a statement. It was actually, I think, 98 or 99, when he said, "Why aren't there more startups?" When I go to MIT or Stanford or Berkeley, I see all these startups. Why aren't there more? And that opened a door at the National Institute of Advanced Studies, which was also on campus at IISc. And I was a visiting faculty there. And we started thinking about the digital divide in India. Because as you imagine, the IT sector was just booming. And a lot of computerization happening, but there was very little once you left the city, right? And so we had a famous anthropologist called M.N. Srinivas, famous from his Delhi University days, and he said, he called this the urban-rural divide in access to information technology. So we started a study group, and that study group ended in something called the Global Village Conference.
Sure.
And in that conference, we had a Bangalore declaration.
Okay.
And in that declaration, there was a question of, shouldn't India be building new devices
Sure.
that is more accessible? And that became the idea behind the Simputer.
Many people don't know that Simputer Sir's team built was actually like an ancestor of today's mobile phone and tablets. So sir, we love to know more about what it was and how was it conceived and what actually made that thing convert into today's technology.
Right. I think of the Simputer as actually a meme. It was actually an idea that led us towards thinking of a new way of information processing and communication. You have to remember the context in India. I think connectivity had been transformed by CDAC and CDOT actually, by the extraordinary creation of the rural exchanges, and STD booths, if you remember.
Yes, yes.
And it was extraordinary how suddenly you had connectivity all over the country. You also had very good groups like the one led by Professor Rajiv Sangal at IIT Kanpur, who worked on machine translation so that you could have digital content in Indian languages. So that language technology work was in progress. Ashok Jhunjhunwala in IIT Madras was working on the last mile connectivity. So what he called wireless local loop and cordect technology, and he had set up, spun off a company called Midas, which was actually working on that. So some aspects of digital access were being addressed, right? But at the device end, we were stuck on PC, right?
Right.
And workstations and so on. The only serious attempt in India to build our own computer had been way back in the 50s.
Yes.
At TIFR, and TIFRAC was what it was called, the automatic calculator of TIFR. And that was a big old vacuum tube calculator, right? After that, nobody had actually built a computer in India from scratch. So the Simputer said, what if we were to actually start domesticating information technology by building a computer? that is completely an original Indian thought,
Right.
And so 7 of us got together and created something called the Simputer Trust. And the Simputer was an acronym that Professor Manohar came up with. He called it the Simple, Inexpensive, Multilingual People's Computer, right?
Right.
Idea was actually one of the Simputer trustees suggested that this could be very helpful for rural banking. So we said, can we make a handheld device that could be secure for doing financial transactions? And so we found there was smart card technology.
Right.
And so we said we'll integrate a smart card into the design so that, and we'll have a touch screen so that you could also do biometrics and so on. And it was designed that way, right? So the Simputer is sometimes viewed as an early meme that, probably was not commercially the big success that all the smartphones and so on brought in. But I think we were ahead of the curve,
Definitely.
So that gave us a lot of satisfaction. In fact, the New York Times called it the greatest invention in information communication technology in 2001, right? So remember, iPhone comes out in 2006 or 7, somewhere in that time frame. So we were quite far ahead in that way. I think altogether maybe 30, 40,000 Simputers were manufactured. They went into many e-governance applications, but it didn't really take off as a retail device, right? So had a lot of enterprise applications, but not as a retail device. There were actually 2 companies that we floated from our lab. One was the Simputer, of course. The other is where my interest in biology comes in. So around the mid-90s, as I had said, people in AI and data science and so on always look for new application areas. And thought leaders in computer science like Don Knuth at Stanford and so on were saying, look at biology. Because there are lots of problems that need computer science kind of skills and approach. So we started a small study group in computational biology. But the more we looked at this, it seemed like inside institutions, these were all still silos, right? There were a few of us who were starting to talk to one another, but that interdisciplinary culture was not there. And so we thought by spinning off Strand Genomics that we can actually create an interdisciplinary environment starting from scratch.
Indian scientists owe a lot to Strand Life Science just because of the bioinformatics pipeline that you created, and they are being used by young researchers all over India. Strand Life Sciences, I think, is one of the most famous enterprise that you created. And any story you want to tell about it, how it went to what it actually is today as one of the most successful companies?
Yeah, I mean, there are several stories to tell about Strand, and I've written some blogs about it and so on. But I think, as you just pointed out, I think building those gold standard pipelines for data analysis in biology, in molecular biology, and particularly in the early days in gene expression and later with genome sequencing and even with proteomics and so on, we were able to build all of that around the Avadis platform. Our good luck was that we were noticed. And the interesting entrepreneurial side to this is that when we built the platform, there were very few takers in India, of course, because no one was doing those types of high throughput experiments. Our breakthrough was in Japan, actually.
Okay.
So when we went and demonstrated this software in Japan, people came to the booth and said, they were willing to become distributors. And one of them was Hitachi. Hitachi. And there was another company called Kurabo.
Okay.
So they became our distributors in Japan. And suddenly we captured the imagination of the Japanese scientists. So we took about 20% of the market in bioinformatics software. And the 20% we were taking away from American companies. So the American companies suddenly noticed us and they said, well, we'll become your global distributors, right?
And the stories like Simputer and Strand Life Sciences, I personally feel should be the part of curriculum for students and colleges and schools, because these are the success stories of entrepreneurship that India needs to know and
Right.
actually celebrate.
I completely agree with you, and I think we've done a poor job of storytelling in science communication, and I'm glad BFI is taking this.
My next question will be around precision health.
Right.
So we talk a lot about this genomics getting incorporated into, let's say, a physician's prescription, like the lab reports and all. Do you see that future happening now?
It will at the right price point, and I think there is still, in some sense, the question of who will pay, how will we pay for this, and this is where, of course, we are working very closely with Reliance to make sure that this comes to an affordable point where then it can scale. And if there is a single directive to the Strand team, it is democratize genomics, right? And so it's happening. I think many things have to be solved for that. I mean, we still are dependent on sequencers that are...
Yeah, that is my next question.
Right.
So with our dependency on import, basically, let it be Illumina, let it be Oxford Nanopore, is India thinking about its own NGS machine in any way, anywhere in the country?
I hope some people are thinking of it.
If you don't know, sir, then it's not happening. That is
right. No, but it's, I think this idea that we need to think very strategically about sovereign technology,
right.
I think is now, I think entering our mind space.
Why can't we work on sequencers of our own? I think we have a lot of nano engineering, nano centers, which can actually do this. There was
some talk about it, but I don't see any full effort. The way we've gone with semiconductors, or actually making it a mission mode project. It would be, and I think again I'll introduce a little bit of a policy perspective here. I think one of the reasons why the West does so well, and particularly the US, in critical technologies like biotechnology, is that it becomes part of the military industrial complex. Okay?
Right.
Now, some people get sort of perturbed by the fact that technology gets driven by the military industrial complex, but that is unfortunately the best way to get innovation in technology going, right? So the fact that we think of biotechnology as having all these biomedical applications, on the other flip side of the coin, it's also biosecurity.
Right.
It's also biosafety, right? It's also surveillance. And so those are pushed by the whole defense establishment, right? And therefore, there is a whole sort of emphasis on developing that. In India, we did that very well with space.
Right.
We did that very well with defense, right? We did it in atomic energy.
Right.
But we didn't take bio as a critical technology. And I think, I really wish that sort of all this Niti Aayog rethink on frontier tech and so on will actually lead us to realize that if we look at biotechnology through that lens of biosafety and biosecurity and sovereignty, I think then we'll see phenomenal strides. So,
Yes, sir, because precision health in India is not possible until we come up with reduced cost, and that reduced cost is directly related to the sequencer itself. What will this precision medicine look like in future?
right, yeah. So precision medicine is actually a very slightly complex topic. Genomics is one part of it. So finally, if for precision medicine to really work, you need a full omics profile, right?
Right.
It's epigenomics. You need proteomics. You need genomics. You need transcriptomics. You need microbiome profiling. So once you build that multi-omics profile of the individual, then you could say you have a kind of digital twin, a biological digital twin.
Right.
Now, some people will argue that that by itself is not enough. You also need to understand what's happening at the cellular level. You need to know what is happening at an immune system level. So that profiling will have to keep graduating to the next levels, right? And so I think then we have to combine that with environment, with nutrition, with various other factors, and eventually you can arrive at a digital twin of every human, every individual, and then you could really talk about precision medicine.
Sir, in the beginning, I mentioned that you have this almost psychic ability to be associated with future technologies. Let it be AI, let it be genomics, and you also now run a CRISPR-based company. And last year, 2025, was a big year for CRISPR technology itself. We heard of a CBS1 deficiency being cured by CRISPR-Cas enzyme technology. We also heard about direwolf coming back into existence.
Right.
Yeah. And also there are talks of in vivo CRISPR use in future. So what does it look like? A brief explanation of what CRISPR actually is and what is the future for the CRISPR technology itself?
Right. So actually, just to give my own perspective on this, I think, as I said, Strand was diagnosing a lot of children with rare genetic disorders. And so back in 2013, when we started doing this, I used to often meet these families, and they would say, "Chalo, ab pata chal gaya hai, kya hai, dawa kahan hai?" Right?
That is so true.
Yeah. So they would keep asking for for this. Of course, we were a diagnostics company, so there was not much that we could do from that perspective. But so I said, when I'm get a little relief from running Strand, then that's what I will focus on. So 2018, I turned 65, and that was also a good year for Ramesh to be fully in charge, and so I stepped back from Strand. And of course, I've remained on the science advisory board and on the board of directors, and that continues even today. But I used that opportunity to go hang out at CMC Vellore quite a bit with pioneers like Dr. Alok Srivastava, who was working on gene therapy for hemophilia, right? And I actually saw that whole process of how from the lab they were able to go all the way to now. I think the first publication in New England Journal of Medicine, which came out about a year ago, actually showed 5 patients over a period of 24 months. The clotting and so on was working, right, with the gene therapy. So that is actually India's first successful success in these cell and gene therapies. CRISPR BITS itself has a focus on 3 platforms that we are developing. One is a diagnostic platform.
Right.
And our thought process there is that point of care diagnostics suddenly became very important, and of course during the pandemic. And of course, RT-PCR became a household term, right? But still, to get to an RT-PCR lab and so on was challenging. Could you actually make kits and devices that could go right to the point of need? So I try to make that distinction between point of care and point of need. And so I call it point of need testing, or which is in French, pont actually means bridge. So this is the bridge to universal healthcare, right? Is being able to address point of need testing, and that's what PathCrisp at CRISPR BITS is working on, how to get to this point of need testing.
Yes.
And just a small technical detail, after this CRISPR guide matches with the pattern that you're looking for, let's say it's a pathogen, in a salmonella pathogen that has been discovered, the guide will find that it is salmonella, and now it'll cut like it's supposed to. The Cas will cut, but you can design Cas enzymes that will not only cut the pattern match area, but also cut any DNA nucleic material in the neighborhood. So if you throw in reporters which have fluorescent tags, it'll start cutting them, and the tag the lights up, right? So you get the fluorescent image, or you could get other types of biotin markers and so on for lateral flow detection. But the point is that all of this cleaving behavior is triggered first by the pattern match. So you will only see the signal of fluorescence or other markers if the match has happened, which means that this is actually a very good confirmatory diagnostic. So because it is actually finding that pattern match. So that's the idea that we're working on. We have a sickle cell test out called Sickle Detect. We have a typhoid detect that is now being tested. We will have an AMR detect. We have, for livestock, we have lumpy skin disease detected in cattle, foot and mouth disease. This will also go into testing food for pathogens. So that's the platform is spinning out a whole bunch of products. The second platform is EdiCrisp, which is actually doing the editing, cut and paste operations, and there we are offering it as a service, and we're working with various research labs, and interestingly also with some international high-profile laboratories which have asked us to do some of this editing. And the third platform, which is in preliminary stages now, is CurieCrisp, where we'd actually like to do an experiment like what you were talking about, the KJ baby at the Children's Hospital of Philadelphia, where in fact my daughter was a fellow at the time when the KJ baby experiment happened. And I think it's, we're at an extraordinary cusp of new type of treatment opportunity using this. Of course, it's the affordability is the question that everybody's asking, because Casgevy was priced at $2.1 million, which of course is completely out of reach. and other gene therapies have also been priced very high.
Just a word on path crisp from what I experienced. So during COVID times, there was a great problem that RT-PCR was taking a significant time, and specifically the variant identification was very difficult. Now using path crisp, you can identify both the presence of virus as well as the variant in 2 to 3 hours only,
Right.
with fraction of the cost.
Right.
So this is what technology looks like, and this is what actually the future is.
Thank you.
So just building on this discussion, sir, there were also many ethical issues that were reported during CRISPR-Cas use, and in 2018, a Chinese scientist actually claimed that he has modified human DNA as per not the ethical guidelines that were.
Right.
Anything you think in India also we need to have some framework around this?
There have been discussions. I recall that before Dr. Samya Swaminathan left for WHO, that is pre-pandemic, she actually ran a whole conference at ICMR where we explored the ethics of gene editing, and by then already this Chinese case, Jianshe, had already, made news. So, so that, the first global observatory on the ethics of, which also looked at ethics, the global observatory was pulled together. I think Dr. Vijay Raghavan represented India at that first observatory. And there was a kind of consensus that we should not edit germline.
Okay.
Editing should be for therapeutic use, can be focused on somatic but not on germline cells. Now that was essentially saying what had happened in China was not acceptable. Right?
Just to add to this,
Right.
now there is a big booming industry in which parents are saving cord blood, and now I think it's going to be $1 billion industry very soon.
Yeah.
So these two things that you're talking about does not match with the current spending of parents on this.
I think cord blood is one thing where you're saying you're preserving stem cells, and so that those could be used for the child or for siblings and so on. There's also IVF, and there is a lot of, in some sense, selection of embryos that happen during the IVF. And so the question is, who is going to regulate whether somebody actually edits those embryos and puts them back, like the Chinese guy did, right? And that's where right now I think the consensus is this should not be allowed. Okay. Will the Indian regulators be, strict about this? That's another question that we'll only know as things evolve. But and of course now the Global Observatory has met 2 more times. Once in England at the Crick Institute, and recently again in Boston. This time in Boston at the IIIS, and now I'm involved as well in the Global Observatory, and we talked about many of these issues. Dr. Roli Verma from ICMR, who's kind of the expert on ethics in many of these biomedical applications, she represented the Indian government at the Global Observatory.
So, sir, as a leading authority on genomics, CRISPR, and cell and gene therapy, what is your recommendation? In today's scenario of scientific discovery, should cord blood be preserved or not? Because people are spending a lot of money on that.
I would defer that question to cell biologists who are actually working on therapeutics, but let me just say what I sense, right? There are 2 things going on. One is that there is a certain vulnerability at the time of the birth of a child when you are told that if you preserve the cord blood, then you're giving your child a chance or the siblings a chance, right? And that's a very vulnerable moment
That is true.
for the parents. And so if it's a little additional expense that they can afford, they're likely to say yes, right? Now the question is that really justified, right? And two things I will say is that there's of course now the whole idea of induced pluripotent stem cells, right? So there is technology that can actually create stem cell lines, without having to go to the embryonic stem cells, right? And so, the question is, are there limitations to what iPSCs can accomplish when it comes to treatment, or do you have to actually use that cord blood? And somebody like Dr. Pooja Agarwal might have a better answer. So I'm going to refrain from actually making that call. But I do think this whole idea of storing cord blood and so on was pre-iPSC, right? And today, we can even create iPSC lines from just a blood draw.
Just a blood draw.
Because you can then create the Buffy codes, PBMCs, and then get the iPSC line. So once that becomes more standard, I feel that the cord blood industry might take a step back, but who knows what. A lot of this also depends on the physicians, the providers, who are at these delivery centers and so on, and what they perceive as right choices. I think, and
If you can convert a normal cell into a stem cell, then the need actually vanishes right away. Sir, whatever you speak becomes a folklore for science community, and one of the terms that you coined, that is graveyard of prototypes, is currently very famous in the startup world.
right.
So your comments on that, and
Sure.
any advice for the startups, because startups are one of our major audience here.
Right. No, I didn't mean that phrase graveyard of prototypes as derogatory, but actually as pointing out that in some sense we have a problem with how we have not dealt with the value of death, right? In startup, many startups get seed funded, but then seed funding will maybe go from an idea to something like a POC, but from POC to go to a product, there is usually a gap, right? And product does not mean just something that's physical, but something that somebody will pay for. Right?
Selling in the market.
Yeah, it has to actually have a need in the market and be demonstrated, right? Now that's that's the problem, is that we have created tens of thousands of startups, and many of them have gone to the prototype stage, right? Maybe beyond POC to even a prototype, but what do they do after that? And that's where we talked a little bit about this graveyard of prototypes. But I think at the same time, I also had mentioned that in addition to the graveyard of prototypes, we also have now created a great human capital of startups and scientists who have become entrepreneurs, who have perhaps not succeeded with their first attempt, but on the other hand have now learnt the process.
Right.
And now these scientists are a great pool of human capital that we can then, bring into the companies that have become sticky and have gone on and been able to, find a bridge over the valley of death and into the next stages. They can now draw on this community because these are scientists who didn't go the traditional postdoc after PhD route necessarily, or at some point did try their hand at entrepreneurship and therefore have a sense of market, a sense of what it takes to bring a product out, what it takes to sell, and all of that. So this talent pool now builds the ecosystem, right? So I think there is a flip side to this graveyard of prototypes, and I didn't want to, leave it at just graveyard of prototypes.
So, what advice will you like to give to the young startups that are there, especially when we talk about US and UK model of innovation? Which model should they adopt, and what are actually the
Right.
pros and cons of both?
Yeah, and I think it's interesting why we only invoke the US and European models, right? Uh, why not Japan?
That is true.
Why not Taiwan? Why not China? Right? Uh, so people used to say, well, Japan is a small country, Taiwan is a small country. They focused on some things, but look at China, right? And the model of how China has done things, we need to understand better, okay? And we need to learn from those models. I think the US model and the EU model, sure. I mean, we all know what that is, and but I think I would urge, whether it's young entrepreneurs or the government policy level, please think about these other models, right? Because they can actually be important learning for us that we need to think about. I think that's just my thought, that the same models of the US and EU may not be the right ones. And the bigger thought in all of this is, let us decolonize our minds.
That is so
Right?
true.
Because I think, we have got so much into thinking these are the only models, right?
Let's build an Indian model.
Let's build an Indian model. I think that's important, right?
That's important,
And
right.
look at what Zoho has done. I'm just so thrilled to see how he has thought about entrepreneurship, how he has taken it forward. I think Wembu's done an amazing job. And I think, so let's think about that in biomedicine and other domains as well. And I think there are lessons there which...
So, any words you have for a young student who has just completed his BTech and wants to open a startup in a deep tech space? So, any words of advice, any roadmap that you want to give them? Because you have done it all, seen it all.
Well, I don't know that I've done it all and seen it all, but I do think it's a little romantic to think that you just jump out of a BTech and you go and do something spectacular. I think obviously people think of Bill Gates or Zuckerberg and so on, Steve Jobs. These guys didn't actually go through formal academic training and then were able to build extraordinary companies. But that's more the exception than the rule. Okay,
That is true.
successful entrepreneurship has typically been associated with people who have actually gone out, worked for a little while, and then taken the entrepreneurial leap. Now, I think so. don't rush into entrepreneurship unless you really think you have something very, very unique, and you've market tested it, the idea, right? I think it's very cool to come up with new ideas that you think will change the world, but unless the market is ready to receive it, there'll be a lot of battles, and that might not be the easiest thing to do for a young student or a youngster just entering into entrepreneurship. I think so. That's the advice that I think you need a little financial stability. You need, even if you're doing it in your late 20s or early 30s, you have several shots at goal. So don't be in a hurry.
Don't be in a hurry, right?
Right? Because I did it at the age of 47.
Yeah.
I became an entrepreneur. That might have been a little too late, but I think typically it's in the early 30s that many people start their entrepreneurial journey, and then they have much more wisdom to do it. Of course, there are some who can start very young and do amazing things, so we shouldn't dissuade them, but I'm saying let's not make this the norm that somebody just finishes a BTech and jumps into being an entrepreneur. Right?
Thank you once again for being with us. Thanks a lot for enlightening us with your wisdom. I think I will never forget this interaction with you in my entire life, and so I also think my audience will also love this podcast today. Thank you, sir. May we also talk in future about some things related to science, related to futuristic technologies with you in coming days. Thank you.
Thank you for having me here.
Thank you, sir.
Pleasure.